So in this lesson, we're looking at the review test for chapter 3. Okay? So the first thing they want you to do is use the vertex and intercepts to graph the equation. Okay? So to find the vertex, when the equation is in this form, where it's ax squared plus bx plus c, the vertex is at negative b over 2a, and then the function evaluated at negative b over 2a. So to find the x value, you do negative b. So in my problem, b is negative 2 over 2 times a, which is an understood 1. So that gives me positive 2 over 2, which gives me 1. To find the y value of the vertex, I plug 1 in there in place of x and simplify. So 1 minus 2 minus 3 gives me a negative 4. So my vertex is at 1 and negative 4. Okay? To find your y-intercept, because that's the easiest one to find, you put a 0 in for x. Okay? So if I look at this graph and I plot the point 1, negative 4, now make sure you're picking the parabola that is the vertical one when you pick it in my math lab. Then my y-intercept is negative 3. My math lab will automatically sketch that parabola for you. Okay? So your axis of symmetry, because we're only doing the vertical parabolas, is always x equals, and it's the x value of your vertex. So x equals 1 for this parabola, because that's the imaginary line right there, that where the graph is a mirror image on both sides. When you're dealing with a vertical parabola, the domain is always negative infinity to positive infinity. Okay? And the range, how low does my graph go? Well, if I look at it, it goes down to negative 4. And how high does it go? Well, it keeps going up to infinity. Okay? So, we're doing the same thing here. We're trying to determine, does it have a minimum or a maximum without graphing it. Well, to determine that, you look at A. Oh, my pen doesn't want to write at the moment, so give me a second here. If A is greater than 0, okay, that means the parabola opens up and you have a minimum, okay? And your range is going to be your y value to positive infinity. Excuse me. If A is less than 0, the graph opens down. You have a maximum, and your range is negative infinity, again, to your y value. So looking at this equation, A is a positive 2. That's greater than 0, so I have a minimum. To find the minimum value and where it occurs, you find the vertex. So my x value is negative b, which is negative 4, over 2a. So that gives me 4 over 4, which gives me 1. And to find the y value, of course, we plug 1 back in. So I get 2 minus 4 minus 7, which gives me a negative 9. So my vertex is at 1, negative 9. So the minimum value is negative 9, and it occurs at x equals 1. Remember, the domain for us is always going to be negative infinity to positive infinity. And since a is greater than 0, my range goes from the y value of negative 9 to positive infinity. Okay, the leading coefficient test you want to look at. The exponent, is it even or is it odd? And the coefficient of the leading term, is it positive or is it negative? Excuse me. If it's even and positive, your graph is rise to the left, rise to the right. Even and negative will fall left, fall right. Odd and positive will fall left, rise right. Odd negative will rise left, fall right. So if I look at my term with the highest power, my exponent is even, my coefficient is negative. So even and negative is down there in that square. So that means it falls to the left and falls to the right. Okay. Number 4. Okay. Find the zeros of the polynomial. So, to find the zeros of the polynomial, you want to set it equal to 0. So x cubed plus 3x squared minus 16x minus 48. So group factor by grouping. So I have an x squared in common here, and I'm left with x plus 3. And in these second two, I have a negative 16. So now I have an x plus 3 in common, and I'm left with x squared minus 16. But x squared minus 16 factors into x plus 4 and x minus 4. Once you get it completely factored, you set each factor equal to 0. So I get x equals negative 3, x equals negative 4, and x equals 4. So the zeros of the polynomial are negative 3, 4, and negative 4. Okay? So then it says, determine the multiplicity of each 0. Well, how many x plus 3's are over here in my problem? 1, because there's an understood exponent of 1. How many x plus 4s? And x minus 4. So there are 3 zeros. So I want this answer. And the multiplicity of all 3 of them is 1. And the last thing asks, what do they do at that 0? Does it touch the x-axis and turn, or does it cross? Okay, if your multiplicity is odd, the graph crosses. If your multiplicity is even, the graph touches and turns. So we're not looking at, is a 0 odd or even? We're looking at the multiplicity up here. And they all have a multiplicity of 1, so they're all odd, so it crosses at all 3. Okay, long division and synthetic division. So when you're using synthetic division, you look at your denominator. If x minus 2 would equal 0, x would equal 2. So you're going to use a 2. And up here we start with x to the 5th, and we reduce by 1 power each time. Because if we're missing a power of x, we have to put a 0. So x to the 5th has a 6. There's no x to the 4th, x to the 3rd, the 2nd, x, and no x. Your first number you bring down and you do nothing with. And then you multiply times that number in front. So 2 times 12 is 24. You add, multiply times 2, add, multiply times 2, add, multiply times 2, add, multiply times 2. Okay, so let me check my work. Oh, I screwed up. I said bring the first number down, and I didn't. I multiplied it, didn't I? We're all going to make those mistakes. 6 times 2 is 12. 0 plus 12. 2 times 12. Negative 5 plus 24. 2 times 19. 38 plus 4. 2 times 42. Negative 5 plus 84. 2 times 79. And 158 plus 4. So there's our answer. We just have to write it out. We started with x to the 5th, so our answer starts with x to the 4th. So 6x to the 4th, 12x cubed, 19x squared, just pulling these coefficients here, 42x, 79 has no variable, and then my remainder goes over the x minus 2. Okay? Okay, so now we're asked to solve an equation, okay? And we're given one of the zeros. So that means we want to use that 0 in synthetic division to divide. So I have a 1, a negative 13, a 47, and a negative 35. Since they told us this is a 0, if I don't get a 0 for remainder, I've done something wrong. So bring down the first number. and then multiply by 1. Add, multiply, add, multiply, add. So now I have x squared minus 12x plus 35 equals 0. You want to ask yourself, are there factors of 35 that add to give you negative 12? And there are a negative 5 and a negative 7. Set each factor equal to 0. So I get 5 and I get 7. But don't forget that that 1 that they gave you is part of the solution also. All right, use the rational theorem, zero theorem to list all possible rational zeros. When you're looking for the possible zeros, you're looking for the factors of the constant or the term with no variable over the factors of the leading coefficient. And the leading coefficient is the coefficient of the term with the highest power. So I want the factors of 8 over the factors of 1. Well, what do you multiply to get 8? Well, we can do 1 and 8, or we can do 2 and 4. Now, in this case, we want a negative 8, but you put plus or minus, because you can do positive 1 times negative 8, or negative 1 times positive 8, okay? And we're dividing that by the factors of 1, which is just 1. So 1 divided by 1 is 1. 8 divided by 1 is 8. 2 divided by 1 is 2. And 4 divided by 1 is 4. So I need 1, 2, 4, and 8, the positive and the negative. Okay, now we have a function, and again, for part A, we want all the possible zeros. So what can you multiply to get 75? Well, let's see, 1 and 75. 3 and 25, 5 and 15, and I think that's it, all divided by the factors of 1. So 1 divided by 1, 1. 75 divided by 1, 75. 3 divided by 1, 3. 25 divided by 1, 25. 5 divided by 1, 5. And 15 divided by 1, 15. So there's my possible zeros. So now it says use synthetic division to test several zeros until you find one. So you pick a value and you try it. Okay? So what do you want to try? Let's try 5. And my numbers over here is 1, negative 3, negative 25, and 75. Going down the first one, that's 5, add, multiply, add, multiply, add. And I got lucky that the first value I found was a 0. So one rational zero is 5. And I'm left with x squared plus 2x minus 15 equals 0. I can factor that because 5 and negative 3 will multiply to the negative 15 and add to give me positive 2. Set each one equal to 0 and solve for x. So my final answer, I have the 5, the negative 5, and the 3. Okay, all possible 0. So we have the factors, of 2 over the factors of 1. So to get 2, it's 1 and 2 divided by the factors of 1 is just 1. So 1 divided by 1 and 2 divided by 1. Now, which one do you want to try? It's a gamble. Let's try 2. Now, in this one, you got to be careful because you've got to put a 0 for that x squared. Otherwise, you screw up the whole problem. Multiply, add, multiply, add, multiply, add. So I'm left with x squared plus 2x minus 1 equals 0. But there are no factors of 1 that will subtract to give us 2. So since this won't factor, we have to use the quadratic formula. And the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's a bad q, so let's rewrite that q. So for this problem, negative b plus or minus b squared minus 4ac all over 2 times a. Simplifying what's under the radical, 2 squared is 4. Negative 4 times 1 times negative 4 is plus 4. So that's the square root of 8. But 8 breaks down into 2 times 2 times 2. And since I have a pair of 2's, I now have 2 plus or minus 2 radical 2 over 2. And then you see how I can't simplify what's under the radical, but the numbers outside are all divisible by 2. So the first rational root I found was 2. But then I also have 1 plus or minus the square root of 2 for my final answer. Okay, to find the vertical asymptotes, you factor the top and you factor the bottom. Okay, if a factor cancels, when you set that factor equal to 0, it's a whole. In this case, nothing factors and nothing cancels. So I just set the denominator equal to 0 and solve. So that's my vertical asymptote, and there are no holes. Okay? And this says type an equation, so you do need to use x equals. Okay, next problem. Find the horizontal asymptote. When you're looking at the horizontal asymptote, you look at the degree of the top and compare it to the degree of the bottom. If the numerator is less than the denominator, and remember, degree is your highest power, then your horizontal asymptote is y equals 0. If your numerator is the same as the denominator, then your horizontal asymptote is y equals a over b, where a and b are the coefficients of your terms. And if the numerator is greater than the denominator, there is no horizontal asymptote. So the degree up top is 1. The degree on the bottom is 2. 1 is less than 2, which means I want to use this rule. So therefore, my horizontal asymptote is y equals 0. All right. We almost got it, guys. 2 more problems. Okay. Solve the inequality. Okay. When you're solving an inequality, remember the first thing you want to do is set it equal to 0, which they did. Factor, which they already did. Excuse me. Set each factor equal to 0. So if x hang on here. Get my pencil going again. If x minus 4 equals 0, we get x equals 4. If x plus 4 equals 0, we get x equals negative 4. So when you think of a number line, we have negative 4 and 4. We need to determine what it does in each area. So if I do a little XY table over here and pick a value from over here, let's say negative 5. Okay? So if I put a negative 5 in there, and solve, that's a negative 9 times a negative 1, which is a positive 9. So this area is positive. Okay? So it's going to be up above. I know I crossed these, so negative 5, 9 is up here somewhere. Okay, let's put a 0 in here. So 0 minus 4 times 0 plus 4. That's a negative 4 times 4, which is a negative 16. So in this area, at 0, here's 0, it's going to be down here at negative 16. What if we put a positive 5 in there? Then we have 5 minus 4 times 5 plus 4, or 1 times 9, which is a positive 9 again. So at 5, we're up here. So here's my graph. Okay, so now you want to look at it. Okay. I want less than. So if I want less than, I want where the graph is below the line. So it's below the line right here, right? So my answer is -4 to 4. Now it's not equal, it's just less than. So since it's not equal, we get parentheses. So we want to graph in between -4 and 4 with parentheses. One more. One more. I don't like that color. It don't show up real good. So let's do a different color. Trying to stick with the darker colors. So x less than equal to 15 minus 2x squared, right? First, we're going to set it equal to 0. So we got to move both of these terms over to the left. When we do, remember their signs change. So now you got to factor that. You can use whatever method works for you to factor. I'm going to do trial and error. So 2x has to be 2 and 1. To 15, it's either 5 and 3 or 3 and 5. So if I put a 3 here and a 5 here, my outside is 10, inside is 3. 10 and 3 won't give me 1. But what if I do a 5 here and a 3 here? 5 and 6 do give me 1. Since I want a +1, it's a +6. I'm going to give myself a little more space here. Okay? +6, -5. Set each one equal to 0. So if 2x minus 5 equals 0, add 5 to both sides and divide by 2. If x plus 3 equals 0, get -3. So on my number line, all I care about is -3 and 5/2. So my XY table, I got to do a value in each area. So if I do -4, okay, and I'm going to plug it right back in here. So I'm doing 2 times -4 squared plus -4. And minus 15. So that's going to be 16. And 2 times 16 is 32 minus 4 minus 15. So 32 minus 4 is 28. So I get a +13. So at -4, I'm up above. What if I put a 0? Well, that one's easy because it's 2 times 0 squared, which is 0, plus 0 minus 15. So that's a -15. So at 0, I'm down below. And then at 5/2, whoops, I want a value bigger than 5/2. So let's say 3, okay? 2 times 3 squared plus 3 minus 15. So 3 squared is 9. So this is 18 plus 3 is 21, minus 15 is 6. So at 3, go up above again. So there's our parabola. Now, this time we want less than or equal. So we want below again. But it can be equal. So since it can be equal, we want the brackets from -3 to 5/2. So we want -3 to 5/2 with brackets. Whoops, wrong one. And that is the review test, guys.